In this video we're going to look at loops and conditions for controlling flow through programs. Please open Notebook 1.2. In Python, the flow of code through a program can be controlled by a variety of different types of statements. In this lecture series we'll consider if, for and while, but you may also come across try statements which specify exception handlers or with statements which allow execution of initialization and finalization code. Immediately following the control flow statement is a colon, which starts a new line which is indented from the left. Let's try this in a Jupyter notebook. So in Python, indentation is everything. Flow through code is entirely indicated through indentation, not end statements like in MATLAB, or brackets as in C. So looking at an example from a real for loop, you can hopefully see that directly after the for statement we have a colon, and then a new line starting in an indented position, shifted from the left-hand side. This happens again after the if statement. The end of control flow is then indicated by returning the code lines to the leftmost side. So this print statement here in fact belongs to the for loop because it starts in line with the rest of the code from the for loop, and this print statement here belongs to the main body of code. So to understand this more fully, let's try writing this loop out from scratch. The purpose of this small section of code is to take a list of integers, loop over all of the numbers in the list, square them, sum them, and print them out if they're less than 3. So starting by writing the list of integers, and initializing the total to 0. Can then write the for loop. For each number in the list units, colon. Now when I press return, the IDE automatically moves my cursor to the right hand side. So I can calculate the square, the total, or sum the number to the total, where this is shorthand for summing this number to our variable total. Create the if statement if the number is less than 3. Right, now I want to return to the for loop, so I press delete. Takes me back in line with the rest of the code from the for loop, so I can print out the square. And then at the end I just want to print out the total summed over all loops. So I delete again, go backwards to the main body of code, so that it'll only print this out right at the end after the loop is finished. And then we can try running it. And there you go. So it's only printing out the numbers when they're less than 3. It prints out the square for every loop and the total only at the end. Now at this point it might be worth talking about what happens when you make an error in your program, or how to go about debugging. So let's create an error in our code by tabbing backwards or deleting out of our loop before we intend to, and run the code again. So now you can see that the Python interpreter has thrown an exception. Here it clearly states the type of error as being an indentation error, as well as the line that the error occurs, which is a line 11, the line following the one that we edited. This is because this line is indented from the left and is expecting to follow a control flow statement. So this is one of the good things about Python. It generally throws up very interpretable error messages. However, if you come across an error that you don't understand, what I strongly advise you to do is copy and paste it into Google, where almost certainly one of the top results will be the Stack Overflow website, which is a forum where experienced programmers provide guidance about the causes of coding errors or challenges. Let's move on to some more specific examples, starting with if statements. So these state that if the current status of the code or variables generated by the code pass some form of Boolean condition, then the code should flow through a subset of lines indicated by the indent, and otherwise it should not. Now, Boolean conditions were covered in the first lecture, so you may want to refresh your memory by going back and checking some of these. However, a few examples of how they might be used with if statements are shown here on the right. So in this example, we create a variable body mass index, or BMI, and we use an if statement to print out whether the BMI is greater than 25. And in the second example, the condition is instead an equality, such that the if statement only runs if a variable has that exact value, in this case, name John. If statements can get a little bit more complex if we add a variety of options through else statements. So here, rather than just having one condition, we can check in serial a list of potential conditions and run different lines of code depending on which condition is met. For example, if BMI is less than 18.5, it will state that the person is underweight. If it's between 18.5 and 25, it states that the person has normal weight. Between 25 and 30, it prints the person is overweight. And for anything else, it prints out the person is obese. You can see this is handled with elif or else if statements and else statements. So following the if, every condition before the last one is an else if, and then the final one is an else. Moving on to for loops, here the generic form is to create a loop variable item, which then during each loop iteration receives a value from a grouped data object, in this case a list, and runs some block of code indicated by the indentation. In this example, it's just a print statement, but often you might want to run some calculations on all the objects in that list. You also have the option to loop over a generic number range created by the Python standard function range, and this ensures that the operations within the for loop are applied some fixed number of times. And you also have the option of nested loops, where here, for every item of the outer loop, the entire inner loop is run once. So hopefully you can see, taking from these two lists, this one for the outer loop and this one for the inner loop, car, dog and bike are printed first after red, then after big, and then after fast. Sometimes you need to use both the list item and the index of the loop, and you can do that with the function enumerate, which will give you first the index and then the list item. So here you can see them printed out for this list, giving us 0, 1, all the way to index 4, printing out the number 5. While loops are similar to if statements in that they evaluate a condition. However, for a while statement, the loop will continue going until the condition is met. So you better be updating the loop variable, else it will carry on indefinitely. For example, here we create a variable count, set it to 0. Our while loop will continue until the count is less than 5. And so we increment our count by 1 each time, meaning that our loop has 5 iterations. And finally, break and continue statements. So as you might imagine, these allow you to break out of a loop or skip some content of a loop. So here, when the code sees a break statement, it stops looping through the list. For this example, it means that when the loop gets to the name John in this list, then it stops completely and ignores the rest of the list. So it just prints out the names up to John. On the other hand, continue statements just skip that item of the list out and then carry on. So here the loop prints every name except for John. So what do we do when we don't have a sequential data object but instead have a dictionary? We use a dictionary iterator called from the function keys. This will loop over all keys in the dictionary, allowing operations to be performed on each key. Here it just prints out the value assigned to the height key. Note that it's so common to loop over keys in a dictionary that this expression can be written in shorthand, dropping the dot keys syntax entirely. Should you need to capture both the key and the value assigned to the key, then you can use the items iterator, and this will provide you with first the key and then the value. And one other example of how we can write in shorthand is list comprehensions. So these collapse all the lines of code from a for loop with just one if statement with a single output expression into a single line appended at each end with a square bracket. The syntax for this is to write the expression first, followed by the loop, and then the if statement. So for the above list, which prints out all numbers in the range from 0 to 4 if they are exactly divisible by 2 and then concatenates it to a hello string. So in a single line, this becomes the print expression, followed by the for loop, followed by the if statement. Now, the if statement is not a necessary component, so you can have list comprehensions with just for loops. So let's now talk about Python functions. These are similar in syntax, indicated by a def statement, followed by the function name, here, my function, our input arguments in curly brackets, and at the end, a colon. The function code is then indented from the left-hand side and finishes with a return statement which includes all of the output arguments. Note, it's possible to have any number of input or output arguments, including 0, where, if you have 0 output arguments, the return statement is not required. Further, for simple functions such as this sum function, it's possible to return in one line, where the calculation is input into the return statement. It's also possible to have optional input arguments. For example, z here is given the default value 0, unless a third argument is specified in the function call, here. It's also possible to have optional input arguments. For example, z here has the default value 0, and so will be ignored unless the function call, shown here, specifies 3 arguments. It's also possible to have multiple optional input arguments, but should you only want to supply one of them, then you need to define which one when you call the function. So here, we're printing out the output of this function for no optional arguments, just one, where here you can see that it's actually the second optional argument, z2, and here with both optional arguments. Finally, arbitrary numbers of input arguments can be specified using the following syntax, so asterisk, and then you can supply an arbitrary list of however many arguments you want. This functionality would also be possible if you supplied X as a list. And when you're writing Python code, which you intend to be read by someone else, for example, your TAs or lecturers, then it is good practice to add a doc string. So this is a block of text sandwiched between triple quotes at the end and the beginning, which declare what the function is for and what its input and output arguments are and what data types they expect or return. So that's the end of this video on loops and if statements. Make sure to finish all of these with a colon and use indentation to indicate what belongs to each code block. The main takeaways from this lecture that you will see time and time again are the for and if statements, so it's really important to be comfortable with them. If you need to iterate over a dictionary, you can do so. So the Python IDE will just implement this using key iterators. And it's important to get familiar with the syntax for functions, including use of def statements, appropriate use of colons and indentation, and how to offer optional input arguments to return outputs using a return statement. Before you go on to the next section, please check your understanding through the Keats quiz.